Okay, in this mini lesson, we're going to talk about special u substitution. This one doesn't happen as much as just normal u substitution, but it does happen every once in a while, and it's useful when you're taking like calc placement tests and things, because you'll see it on there. So this time we're going to integrate x times the square root of 2x minus 1 dx. And so you start this because this is how you would think, hopefully by now, my u would be what's inside the radical, which is fine. So u is going to equal 2x minus 1. But the derivative of u then would be 2 times dx when I move it over, which that doesn't really work, right? Because I need to get rid of this. So what we do is we do kind of a special u substitution. So here's what I want you to do. First of all, we are going to have to divide this by 2. So I'm going to rewrite this as 1/2. This is x, and this is the square root of u. This is now du. The problem is I'm converting my function in terms of u, but I still have an x. So what you have to do, the special u substitution, is you have to change this x in terms of u using your original function, or your original u substitution, I'm sorry. So if u equals 2x minus 1, then u plus 1 divided by 2 would equal x, right? I just solved for x. So I'm going to plug that in there. So I have 1/2. Instead of saying x, x is the same as u plus 1 over 2 times the square root of u du. So now what? Well, now you can distribute. So I'm going to, because this whole thing is there. Ooh, you know what? I'm going to move this 2 out front also. So instead of being a 2 there, that's going to be a 4. Okay, so that's a 4 now because this 2 and this 2, they're both in the denominator of 4. All right, so then I have u plus 1 times the square root of u du. So now I can just distribute this here and here. So I have 1/4. Now my 4 looks nicer. Square root of u times u gives me u to the 3/2 plus square root of u times 1 gives me u to the 1/2 du. And now I have to just integrate that. So 1/4. This, if I add 1 to 3/2, that gives me 5/2. So it's going to be 2/5 u to the 5/2 plus, if I add 1 there, that gives me 3/2. So 2/3 u to the 3/2 plus c. All right, so if I go through and do this, I get 2 u, well, that's not going to be 2. How about we simplify fractions correctly? That's going to give me u to the 5/2 over 10, right? Because 1/4 times 2/5 plus that one's going to give me u to the 3/2. When I take 1/4 times 2/3, that gives me 1/6, so over 6 plus c. And now all I need left, and I know there's lots of steps on these, but they happen, so we have to learn how to do them, as u was 2x minus 1. So I'm going to put that back in there. 2x minus 1, so 5/2 over 10, plus 2x minus 1 to the 3/2 over 6 plus c, and that's our answer. All right, let's look at another special u substitution. Let's integrate, this time let's integrate 2x plus 1 over the square root of x plus 4 dx. So u is going to be the 1 in the square root. So u is x plus 4. The derivative of u then would be 1 times dx when I move the dx over. So that works out nicely. So right now, I know I can put in the square root of u down here, but I don't have anything for here, for this piece right here. So let's solve this one. That would be u minus 4 equals x, if I did that correctly. So I'd have 2 times u minus 4 plus 1, and then du. Now simplify that. And you have u, square root of u in the denominator still. That gives me 2u minus 8 plus 1, so 2u minus 7 du. And then break this one up. Remember, if there's only one term in the denominator, you want to break stuff up. So when I do these two together, that gives me 2u to the positive 1/2 minus 7u to the negative 1/2 du. And then I integrate that. If I integrate that, I add 1. So I have 2 from this 2 times, let's see, 2/3 u to the 3/2 minus, I have my 7. And then if I add 1, that becomes a positive 1/2, so times 2u to the positive 1/2 plus c. And all you have left to do then is to back substitute x plus 4 in, because that's what u was. So I have 4/3 times x plus 4 to the 3/2 minus 14 times x plus 4 to the 1/2 plus c. And that's the special u substitution. All right, watch the next little mini lesson.